If your AI support just dumps docs at users, let's fix it. We'll wire up retrieval, grounded answers, and a clean handoff to humans when the model isn't confident. You probably see long, irrelevant responses or brittle keyword hits. By the end of this video, you will understand a small practical pipeline that finds relevant passages, scores them, cites sources, and opens a ticket when the answer looks risky. No heavy math, just clear steps you can build on in Python today. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced, with simple, concepts-first Python that helps you solve bigger real-world problems. A real support workflow is messy. Users ask about refunds, configurations, or error traces. Support teams add documents and workflows over time. A RAG support bot aims to return precise attributable answers by pairing retrieval from your docs with an answer composition step. Success means fewer wrong automated replies, faster triage, and clear provenance for agents. At small scale, this speeds first response and reduces unnecessary human work. At larger scale, you care about latency and how many documents you fetch. Conceptually, this pipeline does 4 things. First, find candidate documents that mention the user's concern. Second, score and rank those candidates so the best ones float up. Third, compose a short, sourced answer from the top citations. Fourth, if the match looks weak, create a ticket for a human. The strengths are explainability and control. The weakness is simple heuristics can miss nuance, so we add a conservative escalation rule. We will build a tiny toy pipeline that demonstrates each stage. You will see a lexical baseline, a Jaccard similarity upgrade, a top K citation step, an answer composition that quotes a sentence and attaches a source ID, and finally a confidence check that either returns the answer or opens a ticket. This toy maps directly to larger systems where you swap the index and scoring function without changing the control flow. Now we start with a deterministic baseline retrieval example. This snippet performs a tiny lexical search over toy docs to find a best match. We define a small list called docs and a user query queue targeting refund policy. The toke function lowercases text and extracts alphabetic tokens for simple matching. A generator computes overlap counts between query tokens and each doc. Then Max picks the tuple with the highest overlap and returns its index. This crude exact match baseline gives a deterministic, explainable start for retrieval without any ML. The printed index shows which document the naive keyword match selected. Next, we make that match strength more meaningful by scoring similarity. This snippet adds a simple similarity score to quantify match strength. We turn the query into tokens in Qt for reuse, then compute Jaccard similarity for each document as intersection over union. The list SC stores pairs of score and index, so we can retain both quality and identity. Taking max over SC returns the best scoring document and its score. Jaccard dampens spurious matches by penalizing extra unmatched words, making the score more informative than raw counts. The printed value is the best similarity, indicating how strongly the top doc matches. Now we'll pick a small set of documents to use as citations. This snippet ranks and selects the top K docs to use as citations. We reuse the scored list SC and sort it by score descending and index ascending for stable ties. The list comprehension extracts the top indices into top K, which represents our citation set for the final answer. Parameter K controls breadth. Increasing K widens context but may add noise. Decreasing K tightens focus and reduces latency. The printed list shows which documents will be cited in order of relevance. Next, we turn the top citation into a short, sourced reply. This snippet composes a short answer by quoting the best doc with a source tag. We take the top citation from top K and split its text into sentences. The list sent filters sentences that contain the word refund, so the quote stays on topic. Then ANS formats the chosen sentence and appends an inline citation, index, to make provenance explicit. The final string is brief, readable, and attributable, which helps users trust the response. The printed answer shows the quoted claim with its source ID. Finally, we decide whether to answer automatically or escalate to a human. This snippet routes between an answer and human escalation with a ticket ID. We compute a simple confidence as the fraction of query tokens found in the top doc. If that confidence falls below a threshold, we escalate. Otherwise, we answer. The TID is a deterministic hex string derived from the query's character codes, making it stable and human-readable for tracking. Raising the threshold escalates more often for safety. Lowering it favors automated replies and reduces handoffs. The printed route shows whether we answered or created an escalation ticket. To map this toy to a real system, replace the toy docs with your knowledge base. Swap the lexical and Jaccard steps for a vector index like FAISS, and keep the same control logic for citation, provenance, and escalation. The pipeline stays the same, only the retrieval and scoring pieces scale. Recap: it is a retrieval-grounded support pipeline that finds, scores, cites, and escalates. Use it when you need explainable, conservative automation for user-facing support. One caveat: simple token heuristics are brittle for nuanced queries, so tune scoring or use embeddings for better recall. Next step: tune the confidence threshold that decides escalation to balance automation and safety for your collection and users. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.